Okay, welcome back. So our first one, our solution y prime, you could have also selected dy over dx. The 12 becomes a factor, hang on to your x, and drop the exponent by 1. Our second one, we had a little bit more work. We have to keep the f of x for the moment and turn it into x to the 1/5 power. After that, f prime of x is 1/5. X to the 1/5 minus 5/5 is negative 4/5. Our third one, similar to number 2, where we need one moment to leave it in the original function notation. We have not taken a derivative. We're simply making it look different. So 1/7 because we were under a 7th root and had an implied exponent of 1, and the negative sign because we want to bring it out of the denominator. And again, I have not differentiated it. This is not g prime yet. Once I have it in this form, now I can take the derivative. And g prime of x, I would hang on to that negative 1/7, and x subtracts 7/7 from negative 1/7, and we're at negative 8/7 for an exponent. Our fourth problem, hopefully it didn't trick you, y prime pi squared. Pi is a constant, so pi squared is still a constant, so 0. Similar for number 5, e is a constant, so h prime of x is also 0. Anytime it's derivative of a constant, even if that constant happens to have either an English or a Greek letter representing it, if it's a constant, its derivative is always 0. Okay, let's see another couple of nice properties here. This one we can do a quick sketch of a proof. Consider f of x is c times function g of x. So c here is in the reals. We're going to assume, to make it not boring, c is not just a plain boring 0. Technically would still work, but both functions would be just the plain boring x-axis. So we want it to be interesting, but at least in the real numbers. Well then, f of the quantity x plus h, well, everywhere I had an x, I'll plug in an x plus h. So c doesn't have an x, but g of x, the of part, does have an x. Now it's g of x plus h. So then f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. And we can do a little bit of substitution there then. So f prime of x is the limit as h goes to 0 of f of the quantity x plus h. We found out that that is c. I'll make it look like a c this time. Sorry, my hand slipped a little bit. C times g of the quantity x plus h minus the original f of x. The original f of x was c times g of x. And we have our h downstairs still. So you might notice that we can factor c from both of those. And since that's not going to be affected by h going to 0, we can in fact move it in front of the limit and say that f prime of x is c times the limit as h goes to 0 of g of the quantity x plus h minus g of x all over h. This definition should look familiar. This looks like just the plain definition for f prime, only with g's involved, so that is g prime. So f prime of x is c times g prime of x. This is the constant multiple property. If y equals c f of x, then dy dx is c times f prime of x. So in other words, we don't always have to have an x squared. We can have a y equals 7x squared. If we want to differentiate that, then y prime is 7 times whatever we would do to differentiate x squared. So 2x to the first. Exponent becomes a factor. Drop 1 off of your exponent. And then we just have a little bit of cleanup to do, so that would be a 14x. So just, we had a pair of factors to put together. Let's see, let's try a g of x is 3 over 5x to the 6. So this one, again, I need to take one moment to rewrite it. So I hang on to my coefficient of 3/5 and say it's times x to the negative 6. And then after that, same rules as before. So g prime of x, hang on to that 3/5. The negative 6 is now a factor. If you want it over 1, you can. You don't need to write that, though. X to the negative 6 minus 1 is negative 7th power. And then it's just cleaning it up. So positive by a negative, our coefficient is now a negative 18/5 times x to the negative 7th, and that would be our derivative. So we have you all try one. We'll try h of x is 4 over 3 square root of x. So give that one a spin, unpause it when you're done. Okay, welcome back. So first step is just rewriting. So 4/3 times x to the negative 1/2 power. Negative because our variable was in the denominator, we moved it to the numerator. 1/2 because we have the implied index of 2 if we write out a square root without a written index, and an applied exponent of 1 if we write a variable without a power next to it. This is h of x, not h prime of x. So our last step is now we can find h prime of x. So 4/3 times, now that negative 1/2 is also a factor, and x to the negative 1/2 minus 2/2 is negative 3/2. So h prime of x is, let's see, negative 2/3 x to the negative 3/2 power. So the 4 and the 2 we reduced. Okay, one more nice cute little sort of mini proof derivation to do. Next we'll consider f of x equal to m of x plus n of x. We'll just use it, we'll call it a let line. Consider let f of x be the sum. So f of x plus h, m of x plus h plus n of x plus h. So if I'm looking for x plus h, I rewrite the f of x, but everywhere I had an x, I have an x plus h. F prime of x, now we put that to work for us. Limit as h goes to 0 of f of x plus h is m of the quantity x plus h plus n of the quantity x plus h minus the original m of x plus n of x all over h. So f of x plus h minus f of x all over h. Certainly I can knock down those parentheses. Still have the limit as h goes to 0. And we can knock down the parentheses, m of x plus h plus n of x plus h minus m of x. Watch your signs here, minus n of x, since we have to knock down those grouping symbols all over h. Quick little side problem, I'll do it up top here. Now the same thing that lets you in your head just instantly tell me that that's worth 3/7 and you don't even have to really think about it. The step that you usually do in your head is say, okay, well, I keep that common denominator, add or subtract what's upstairs. I just want to remind you that equal signs are not a one-way street. If we can start here and go there, we can also start this way and break it up and say, okay, I'll put each term over the common denominator. And that's exactly what I'm going to do here. I'm going to grab the things that are alike, though. But each is over a common denominator of h. So f prime of x is the limit as h goes to 0 of m of x plus h minus m of x all over common denominator h plus n of x plus h minus n of x all over h. And hopefully we'll recognize the format. Okay, this is a derivative, so is this. So f prime of x is m prime of x plus n prime of x. I happen to write it with addition. It will work the same way with subtraction. So the sum and difference property, if we have f of x is m of x plus or minus n of x, then f prime of x is m prime of x plus or minus n prime of x. So addition or subtraction will work that way. So now we can handle multiple terms. They can ask us to do things like differentiate. In other words, find the derivative. They can give us a nice three-term polynomial, 7x squared minus 8x plus 942. Well, because of our product rule and our sum and difference rule, no problem. Well, I should call it constant multiple rule, the constant multiple rule and the sum difference rule. Nobody has to be adjusted here. I don't have any variables in a denominator or underneath a radical. I can dive right into f prime. So 7 times 2x to the first, 2 minus 1 is 1, minus 8 times 1x to the 0, plus derivative of any constant, no matter how big, always, always, always a nice big fat 0. You don't have to write it that cartoonishly huge. I was just putting it there for emphasis. So f prime of x, 14x minus 8. Remember, x to the 0 is worth 1. So I have you all try one out. Let's see, I'll have you find d dx. So this is saying find the derivative of what's inside. We'll do, let's see, 7 over x cubed minus 5/4 of x squared plus 5 over 7x squared. So see if you can give that one a spin. You will need to do a little manipulating before you differentiate. Okay, welcome back. So we'll hang on to this since we haven't done the derivative yet. We're just rewriting the original. 7x to the negative third minus 5/4 x squared plus 5/7 x to the now negative second power. So then after that, just using all the properties that we've learned so far, I'm used to putting something on the left-hand side. This one is when they give us just an expression as opposed to all the other ones where they've given us an equation. So I'll hang on to the 7. Negative 3, the exponent is now a factor. Hang on to your x and subtract 1 from that exponent. Watch your sign work with these negatives. Hang on to the negative 5/4. 2 is now a factor. Hang on to your base. Subtract 1 from that exponent. Do the same thing with our last term. Hang on to the coefficient. Exponent is now a factor. Keep that base. Subtract 1 from your exponent. So then this would be negative 21 x to the negative 4th minus 5/2 x. So x to the first we typically just write as x. And then minus 10/7 x to the negative third. And that's as far as we need to take that one. All right. Now, one last thing I want to do a little bit more practice with, tangent lines, the equation of a tangent line. So find the equation. EQN is common abbreviation for equation of the tangent line to what function I pick. F of x is 3x to the fourth minus 7x squared plus 5 at x equals, we'll do a nice pretty value 1. So if they want the equation of a line, I need two things. I need a point and I need a slope. So to find the point, I just go to the original. I find f of 1. So 3 by 1 to the fourth minus 7 by 1 squared plus 5. So let's say 3 minus 7, negative 4 plus 5 is 1. As far as slope, remember slope is an idea of a rate of change. In other words, a derivative. So I would find f prime of x. So that would be, hang on to the 3. Exponent of 4 is now a factor of 4. Keep the base, drop 1 off of your exponent. Hang on to the minus 7. 2 becomes now a factor. Hang on to the base, drop 1 off of your exponent. Derivative of a constant is always 0. So f prime of x, after a little cleanup, 12x cubed minus 14x. And to find what slope we have when x is 1, we find f prime of 1. So 12 by 1 cubed minus 14 by 1 is negative 2. So this is our rate of change. We'll treat it like the slope because it is the slope of the tangent line. So then just change in y is our slope times our change in x. So y minus 1 is negative 2x plus 2. So y is negative 2x plus 3. And again, if you want to make a quick check of your tangent line, graph the original equation in your calculator, put your tangent line in as y2, and then sort of set your window up so that you're focused on values nearby your ordered pair, in this case the 0.11, and you should see a curve and a line meeting at whatever value you get here. Okay. So let's see. One more that I want to try. In fact, we'll just build that off of our last one. So the pertinent information from the last page, f of x was 3x to the fourth minus 7x squared plus 5. And f prime of x landed us at 12x cubed minus 14x. There's one more thing that we'll do with this. We'll find all x st such that f is a horizontal tangent line. TL is the common abbreviation for tangent line. Well, remember, f prime gives us the slope of our tangent lines at different points. If it's horizontal, that means that it has a slope of 0. So we simply set this thing equal to 0. 0 is equal to 12x cubed minus 14 times x. And we can do a little bit of factoring there. Let's see, we can pull a 2x, leaving us a 6x squared minus 7. So either 2x is 0 or 6x squared minus 7 is 0. So x equals 0, that's one place where we have a horizontal tangent line. Or the 6x squared is 7, so x squared is 7, 6. So x is plus or minus square root of 7, 6, and we'll just do a little rationalizing there. So we'll hit the top and bottom with square root of 6. So plus or minus root 42 over 6. So those are places where we would have horizontal tangent lines. So horizontal tangent line, take the derivative, set it to 0, and solve it. So there's our 3 places where we have horizontal tangent lines. So in section, this was 2-5. I would recommend 1 to 55 on the odds, 57 to 64 all, and number 89. And I'll turn on also the author's sort of generic 2.5 homework as well. All right, if you have any questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.